Hello students, I would like to say welcome to all of you in this Misostudy video class, and it is clear from this heading, that is the first slide. We are about to start a discussion of NEET, that is Medical Entrance Exam Pattern exercise, and that too from a very interesting and simple chapter. Simple, why I am saying, just by learning 2 or 3 simple concepts and just few formulae, ensure that you are going to score 4 to 8 marks, 1 or 2 questions. So in your entrance exam, out of 45 physics questions, if without any effort, within 2 minutes, you can attempt 2 questions correctly, you can assume the importance or the weightage of those 8 marks finally in your rank. Fine. So don't consider this chapter useless. If you want to score a good rank, make your habit to pick even a single mark from each possible method. Fine. Here I am offering you 8 marks. So you can imagine the situation. So this chapter, what I will do, I will try my best to explain or revise all your concepts and formulae in this particular chapter. So let's start this discussion with this approach. And one thing that is important over here in this chapter, there are certain calculations and they are slightly long. Fine. So just try to learn them, okay, just by some practice. I hope you will be find yourself in a very comfortable position. Here is your first question. Magnetic field in a plane EM wave, electromagnetic wave, is given by B is equal to B naught sine kz plus omega t. I am just mentioning the standard equation, okay, so that you can visualize what exactly the standard or ideal equation is. Now you have to find the electric field. Students, as we know that E, B and C all are perpendicular to each other. Fine. Now if B is along y axis as given in the question, obviously E cannot be along y axis, okay. E definitely will have to be either in z or x axis, okay. Let's start taking the look of inside terms. Here the wave number is along z axis. So obviously the possibility for E electric field is remaining 1 x. Fine. It means A cannot be an option, C cannot be an option. Only possibility is Ex and Ex, this B and D. This is not possible. Okay, then try to find out which one is correct option, B or D. Fine. So what is the relation between electric field, magnetic field and speed of the EM wave, that is speed of light? So relation is this way. E is equal to C naught or C, simply you can say speed of light, so there is no point of putting naught. E naught rather is equal to C B naught, okay. So E naught is equal to C means, let me allow to put the values, 3 into 10 to the power 8, okay. And what is the value of V naught? It is given in the problem, 2 into 10 to the power minus 7. So what you will get? You will get 3 to the 6 multiplied by 10, that is 60 volt per meter. Fine. So now one thing is crystal clear, that A and C, they are not possible, and now B is also not possible. Why? Because the magnitude of electric field is 60. So itself the question is saying that D is the correct option. Approach I explained, logic also I explained. So if you start learning in this fashion for physics, obviously you will score good marks in physics, and physics is the subject which for medical students ultimately decide whether you are going to become a doctor or not a doctor. Fine. So, because of this reason it is important subject, so please do not take it lightly and do not take it very in a very difficult manners also. Now, it comes to obtain a displacement current of 0.1 ampere between the plates of a capacitor of 0.1 microfarad, the rate of change of potential difference between the plates should be how much? Yes, if you are even unable to understand the problem, one thing you can say surely that in this particular question we are just trying to emphasize our focus on the very first topic of this chapter. Try to recall, this chapter starts the discussion with the idea of displacement current. And why Maxwell introduced this idea, that has been explained over there. Actually it was an Ampere's equation and rectified by Maxwell, and because of this only Maxwell's ultimately combined out of two forces. There are 6 forces in nature, basic fundamental forces, and Maxwell combined these 2 forces, that is electric force and magnetic. Now scientists are working on string theory. Fine, they are in a process, I mean they are trying to combine all those forces. String means by combining 6 forces they want to create a string, okay, strong string. Nobody knows what will be the future after that, because just by combining these 2 forces, it's your miraculous changes in the approach of various experimental aspects. So let me allow to mention it in a different fashion. What exactly the situation? Displacement current ID is given as epsilon naught del phi E by dt. So let me allow to write down the formula, that is ID is equal to epsilon naught del phi E by dt. Okay, phi is what? Electric flux. So phi E is E A. Fine. In chapter 2 of starting of electromagnetism, electrodynamics, you learned this. Now also V is equal to E D. Okay. So from here what I can say? I can say E is equal to V by D. Fine. Now replace the value of V by D in this particular relation, that is phi E is equal to EA. So let me allow to use this space. Fine, I explained what exactly we are trying to do. So now from here I can write down ID is equal to epsilon naught del E, let me write down it like in this fashion, d by dt E A. Okay. In place of E I can write down B by D. Okay. So ID is equal to epsilon naught del by del T E, that is V by D into A. Now we will do some makeup of this particular equation and then I will get a very beautiful relation. What exactly the makeup? The makeup is, take this A and D out, because A is the plate area which is constant and D is the plate spacing between the plates of the capacitor. So that is also constant. Okay. So this is epsilon naught A by D del V by del T. Now as C is equal to epsilon naught A by D, so what I can say? I can say ID is equal to, that is C into del V by del T. Fine. What exactly we are supposed to find? We are supposed to find the rate of change of potential difference, that is del V by del T. Fine. So what I will do? I will use this space just to mention this solution, that is del V by del T is equal to, take a look over here, you will find ID by C. So it is ID by C. Take the values out. 0.1 and C is 0.1 into 10 to the power minus 6. So ultimately you will get the correct answer as 10 to the power 5 volt per second. Fine. So this question is not a difficult one. Simply you have to put the values and you should know this relation that has been explained in the starting of this chapter. So that's why I explained the idea, and this way I explained you the formula. So if this approach you are going to adapt during the preparation, then inside the examination hall you will definitely enjoy the questions in physics more than the questions of zoology, botany or chemistry. Fine, because there you will have to remember one beautiful aspect of physics is, even if the concept is clear in your mind, you can try the question. But in zoology, botany, either you know that or you don't know that. Fine, digital terminology. Here it is analog approach. So that's why it's more beautiful subject. Let's move on to the question number 3. Now, which waves are used for taking photograph of Earth under foggy conditions from great heights? Actually, this question I placed just for the sake of putting some focus on to one diagram which is mentioned not only in your textbook but also some other supporting books that normally students follow to adapt or learn various things in physics. That is the electromagnetic wave spectrum. Fine, starting from cosmic rays, then gamma rays, then X-rays and so on. Then what are the properties, means in terms of frequency, means in terms of energy, means in terms of utilization. So this is something that is based upon the phenomena of that utilization. My suggestion is to all of you, once in a while you should take the look of that particular diagram. So by that method you can learn many things. So here ultraviolet rays, obviously you cannot use them for the photography during the foggy conditions. Visible rays, not impossible, even in foggy conditions you cannot watch anything, then how the camera will? Fine, normal camera will only record the fog. And then microwaves and infrareds. Microwaves are normally used in our day-to-day life for cooking purposes, for heating purposes, fine, because their wavelength is large, so their energy is less. IR sensing, this term is normally associated with the satellites, remote sensing satellites. IR photography, fine. So that's why this infrared photography is the correct option for this particular condition of taking photograph of Earth under foggy conditions, fine. This is also the method by which you can eliminate wrong options, and this is something that you can do only if you have the clear understanding of all the properties of these particular radiations, fine. Here comes your question number 4. Imagine the situation. The RMS value of electric field of light coming from the sun is 720 Newton per coulomb, that is E RMS is equal to 720 Newton per coulomb, fine. What is the average total energy density of EM waves? My only point by picking this question is that you should at least few times practice the formulae of this chapter by writing. If you are solving a problem, fine, and you are writing the formula few times, then obviously you will find yourself in a very comfortable situation. So this question is totally based upon that phenomena and what exactly the idea of this average total energy density, fine. So let's try to find out the solution. UT, that is total energy density, is half epsilon naught E RMS square. This is the formula which you are supposed to use, fine. Imagine one more situation. electric field coming out, so average energy density means whatever is the reflection, that you also have to consider. So basically UT is epsilon naught E RMS square. Fine. Now you have to just put the values in this particular relation. So epsilon naught, you know, 8.85 into 10 to the power minus 12, and that ERMS is given as 720 whole square. Why in the starting of this video shoot I mentioned that in this particular chapter only two aspects are important. One is concepts, just 2 or 3, and some formulae. Also important is calculation, because if you don't have the practice, what you will do? You will start multiplying 720 with 720, at least 40 to 50 seconds that will take. Then you will have to multiply that resultant with 8.85, that will take some time. And in between, just by rushing, if you committed even a single digit mistake, you are going to land in a wrong place. So if you have good practice of calculating fast, obviously you can get the answer very properly. Fine. So after solving UT is equal to 4.58 into 10 to the power minus 6 joule per meter cube. Okay. So the question is simple. Obviously I am not going to solve it over here by multiplying, by dividing. Okay. So I simply mentioned that yes, you should up to some extent try to calculate correctly the values. Those are required for finding some essential and important results. Now before moving on to next problem, I hope, I should mention it, I hope you will realize that yes, for these type of chapters, say for example one more chapter, and that is magnetism and matter. That chapter has also not lot of complicated calculations or something, just few formulae and some amount of calculation, and 1 or 2 questions also from that chapter. Fine. So this way it is like you can ensure in totality that these simple chapters will give you very good marks. Okay. Let's come on to the problem number 5. In this problem, without any calculation, I will show you how you can first eliminate some wrong options, and you can zero in on or near to the right option. What should be the approach? Listen carefully. An electromagnetic wave of frequency nu is equal to 3 into 10 to the power 6 hertz, 3 megahertz, passes from vacuum into a dielectric medium. Now if you just check your basics with this statement, you will say moment this EM wave will pass from vacuum to any dielectric medium, then its velocity is bound to reduce. Simple fact that will definitely come in your mind. Okay. So if velocity is reduced, and you know that frequency is the characteristic of the source, so frequency will not change, so ultimately lambda will have to change. Fine, because velocity is changing. Why? Because it is now moving in a medium. So with permittivity epsilon is equal to 4, then out of these 4 which option is correct? So first point that should come in your mind, frequency will remain fixed, unchanged, constant. Okay. So frequency remains unchanged, this first statement may be possible that it is correct. Okay. So don't remove it, hold on for this particular statement, hold on. Then comes B, wavelength is double and frequency becomes half. You know frequency will not change, outrightly reject it. Okay. Now come on to the C, wavelength is halved and frequency remains unchanged. Okay. Frequency remains unchanged, so there is possibility. Okay. So let's hold on for this particular option. Then D, wavelength and frequency both remains unchanged. It is also not possible. Why? Frequency remains unchanged, but there are 3 quantities, that is nu is equal to C upon lambda. and then nu is equal to V upon lambda prime. Because this is fixed, same. So if V is changing, lambda will have to change, and what this fourth option is saying, lambda is unchanged. So this fourth option is also not possible. So ultimately I have two you can say possible correct options. One is A and another is C. So we will try to find out which one is the correct option. What I will do, I will say B and D now rejected. So you have zeroed in close to the correct option. Okay, let's try to find out. So V is equal to, V is the velocity of light in any medium, that is C upon under root epsilon r mu r. Fine. Now from here what I can write down? I can write down V is equal to C upon under root mu r, sorry, epsilon r. Epsilon r, it is given. Fine. Now put the value of epsilon r. So 3 into 10 to the power 8 meter per second upon 4 in under root, so it will give you 2. So it is 1.5 into 10 to the power 8 meter per second. Now I have velocity, so easily I can find out lambda prime. How? Let me allow to use this space. That is nu is equal to 3 into 10 to the power 8 upon lambda, and nu is equal to 1.5 into 10 to the power 8 lambda prime. Let us say this is equation number 1, let us say it is equation number 2. So we can say from 1 and 2, what we can say, that 3 into 10 to the power 8 upon lambda is equal to 1.5 into 10 to the power 8 upon lambda prime. So easily we can find the value of lambda prime in terms of lambda. Fine, and it is going to be half of that. So correct option is wavelength is half and frequency remains unchanged. Basically lambda prime you will get it as what, that is 50 meter. Fine. So this question is not a very difficult one, but yes, if you just take a look of this particular expression, this expression is required, then some changes and then putting the values together. So with this we also learned a good technique of how you can try to reach close to the correct option. Fine. Now you need not to waste your time on wrong options which you already discarded on the basis of your understanding and concepts. Fine. So this is the, I think, best way of putting your knowledge in totality to get out the correct solution. Now with this we are free to move away from this question number 5 onto question number 6. And here it is your question number 6. Yes, I used the this magnetic field expression similar as I used in question number 1, because my idea is to show you something. Fine, it is not important what is the number. Ultimately equation is By is equal to B naught sin kx plus omega t. Okay. In an electromagnetic wave, the magnetic field is given by this expression. What is the intensity of electromagnetic wave? About means near about, 6, 10, 5 or 2, or exactly they are trying to find out what exactly the intensity of electromagnetic wave. So obviously the formula is required over here for the understanding. Fine, and only then we will able to find out the correct option. Now let us try to find out what will be the value of this intensity. So let me allow to mention the formula over here. Intensity is 1 by 2 B naught square upon mu naught. Fine. I is equal to half B naught square upon mu naught. This is the general formula of intensity. Now what we will do, we will put the values over here and try to solve it. So now this formula is mentioned just below the question, so that at any point of time you can revise it. I is equal to 1 by 2. What is the value of B? That is 2 into 10 to the power minus 7. So 2 into 10 to the power minus 7 whole square upon mu naught. What is the value of mu naught? Mu naught is 4 pi into 10 to the power minus 7. Now if you solve it, and yes, that C, sorry, that C is missing over here. I is equal to half B naught square mu naught upon C. That's why I am emphasizing that you should practice the formula by writing again and again. Fine. Just because of the habit, my hand was trying to find out the value of speed of light. Okay. So now it is in totality the final expression, and if you solve it over here, you will easily get the value as 2 into 2 into 10 to the power minus 14 upon, sorry, 3 also, 3 into 10 to the power 8, that is also here, upon 2 into 4 into 3.14 into 10 to the power minus 7. So I is nearly equal to 5 watt per meter square. Fine. Now again you will realize the importance of the calculation. See, 2 and 2 cancelled, then ultimately this 2 and 2 over here, fine, and then this 3. So you can say yes, some fast calculation methods you should learn. Otherwise unnecessarily you will waste your 1 or 2 minute time onto this calculation. And if in between that, just because of the panic approach, let's say you committed a simple mistake in calculation, ultimately you are going to land in a wrong place, and one negative question means some minus marks. You are unable to score that 4 marks, but you are also losing 1 mark from your correct question. So that negative approach is not a very useful approach. So that's why let's do some sort of practice. Fine. And the main emphasis of these questions that we are providing in Misostudy to you is not just merely numbers. We are just focusing on to the quality, not quantity. Here is your 7th question. Radiations of intensity 0.5 watt per meter square are striking a metal plate. The pressure on the plate. Now, for students preparing for you can say engineering entrance exam, JEE and so on, JEE mains, JEE advanced, up to some extent it is quite easy for them to understand because of the mathematics. Over here as such no mathematics is involved, simple calculation is required, but few of you from medical stream may think on this line, how light can put pressure. Although in this particular chapter we discussed about the Poynting vector, we discussed about the pressure offered by the light in 2 conditions. One is, that is case 1, pressure P is equal to I by C. Case 2 is, P is equal to 2I by C. Case 2 is 2I by C. Why? Because here reflection is taking place. Reflection. Okay. So if reflection is taking place, this is the formula. Now if it is mentioned in the problem, good to use either one, and if it is not mentioned in the question, suggestion is use reflection case, because if a metal surface, obviously polished surface in general, smooth surface, so if light is striking, reflection will definitely take place. If the surface is blurred, if the surface is rough, then it may possible that reflection is not taking place. But it is specifically mentioned that metal plate, So reflection will take place. So what we will do, just on the basis of this understanding, we will use the case number 2 formula, that is 2I by C. So let's take a look over here. So pressure P is equal to 2 into 0.5 upon C, that is 3 into 10 to the power 8 meter per second. Now it's your turn to calculate it, that is 5 2s are 10.1, that is 1 by 3. 1 by 3 means something like 0.1667, something like that, and then 10 to the power minus 8. So obviously A is your correct option. Now option is simple, calculation is simple in this problem, but this concept, whether we should use I by C or I should use 2I by C, may create some confusion. That's why I mentioned that in physics sometimes in between the lines so many things are hidden. Fine. So that way you have to follow this approach of what exactly is mentioned and what exactly the meaning of that particular sentence. Just because of this is striking a metal, I am considering reflection. I hope you can understand why exactly it is important. Then students, it comes question number 8. Now what exactly this problem is? Frequencies higher than 10 megahertz, that is 1 into 10 to the power 7 hertz, were found not being reflected by ionosphere. Not reflected means absorbed, allowed, on a particular day at a particular place. This is very important. Particular day, it's not like Sunday or Monday, but particular day and place. What is the meaning of these two terms? Particular day means, let's say on that particular day, let's say density or humidity or light or something like that, sunlight. And place means just above various places on the earth's surface. Fine. In Antarctic, the ozone layer formation is something different. At equator, something different. At a place where lot of pollution is there, something different. So all these parameters are important. Fine. The maximum electron density of ionosphere on that day was near how much? Purely a formula is required for understanding of this particular concept. Fine. So electron density formula which is used over here, slightly different question. Okay, few of you may say, sir, this is something that we not learned in this chapter. You learned in this chapter. Why? Because during the discussion of various these radiations, gamma rays, alpha rays and so on, these gamma rays, X-rays, alpha and beta are not that radiation, they are the particles. You have studied these specific properties. Fine. So now you should know 1 into 10 to the power 7 hertz comes in which category? Fine. And this is something you can judge only if you have the fair understanding, or you can say you can recall these properties. There are 7-8 people and you should know basic characteristics of all these people, starting from cosmic rays, gamma rays, X-rays, then your ultraviolet, then your visible part, then your infrared, then your microwaves and so on so forth, radio waves, long waves. Fine. We discussed very deeply, very properly with various properties, frequency range in our videos. If regularly you are watching, definitely you will get benefit from that. So over here let me mention the formula, that is mu c is equal to 9 under root n max. This is the formula. Maybe it may be mentioned with some different expression in other books, but this is in general the formula. So what you should do with this formula, n max is equal to upon 9 9 ja 81. Fine, no problem, simply multiply it. So n max is equal to 1 into 10 to the power 7 square, that will give you 1 into 10 to the power 14 upon 81. Fine. So by this you can easily find out the value, and yes, that C term is also here. Fine, that C term is also here. So exactly if you divide 1 by 81, so somewhere you will get 0.0, again 0, 0, so 1 time. Fine, and this way if you calculate, the answer will be somewhere 1.24. okay, because if assume it as 80 rather than 81, then easily you can calculate it. So answer is somewhere going to be 1.24. with the 80 it will be like 1.25. fine, and this is something, yes, you can learn it just by practice. You can say you may have solved this problem and now you are showing that you know a lot of things. It is just by practice you can do like these things. Fine, so the correct answer is going to be your B, 1.24 into 10 to the power 12 per meter cube. Yes, some extent you may say we are not very much familiar with this person. That's why I am requesting, make your friends, various friends from this chapter, and they will definitely make your preparation very simple. The more you will make friendship with these terms, the more marks you will score. Simple concept. So now it comes question number 9. What is the order of energy of X-rays? EX, ER, radio waves and microwaves. Fine. Now, from where we are picking this question? Once again, that same electromagnetic spectrum. Because in electromagnetic spectrum, if you have the clarity of, you can say, frequency that is associated with different radiations, you will definitely find out that frequency of X-rays is very high, just below the cosmic rays. So they have maximum energy. Okay, it means C and D anyway not possible. What they are saying? They are saying EM is more than ER and so on. EM is something like that. Okay. So what about the radio waves? Then what about the microwaves? So my suggestion is, correct option is not a problem, but my suggestion is revise, and this is going to be very useful in totality. Revise EM spectrum, obviously on the basis of variation of lambda and nu, these two terms. Fine, and you can handle either this question or question number, I think it was 3, which was associated with the infrared camera sensing with remote sensing satellites. So all these questions you can answer using this type of concept. Fine. So accordingly, now here we would like to move. Okay, you may ask which one is the correct option. So B is the correct option accordingly. Fine. Then comes your next question, that is question number 10. Which of the following set belongs to EM waves? Once again the same concept of frequency variation or wavelength variation. Alpha rays, they are particles basically. Alpha particles means twice He4. So they are not part of the electromagnetic spectrum. Sound wave. Sound wave means mechanical longitudinal waves. So they cannot be the part of EM waves. EM waves are not mechanical waves. Beta rays, electrons, not possible. Sound waves, once again mechanical longitudinal waves. Cosmic rays, yes, they are from this EM waves, but with cosmic rays, just because of their friendship with mechanical longitudinal waves, it also loses its charm or its beauty. So it is also not correct option. X-rays, yes, just after cosmic rays, X-rays. So finally light waves, visible part, that's why I mentioned cosmic rays, then your gamma rays, then X-rays, then ultraviolet, then visible, then infrared, then radio waves, then long waves, then microwaves, so on and so forth. Fine, there are 8 or 9 type of radiations. So please keep revising this way. So here it is your D is the correct option. So finally students, I would like to say that we should take a stop over here. Very soon in future we will come back with more number of good questions from these topics. Fine, and just by revising these questions and the way I explained, keep focusing onto core areas of concepts and calculations, definitely you will enjoy this topic. So with this positive note, I would like to say thanks to all of you for watching this video. Take care of yourself. Thank you.